Hey, in this one I would like to present the tee and splice syscall, which are part of the zero copy of a syscall family like send file, which I presented last time. And it's just a way to manipulate data streams within the kernel without ever going to user space. And of course, you can see how that would be more efficient for some applications. So like, yeah, if you have some kind of file or some kind of networking interface or a terminal and whatnot, and you need to transfer data between these different places, well, you can use these syscalls instead of read and write to avoid copying data and ever going to user space. So yeah, let me just show you a little example that I prepared. So this example is just a TCP, let's say, I don't know, a TCP proxy. So I just have one TCP connection for the input, and then I need to distribute the exact same data to two other TCP endpoint. And so this is a lot of TCP boilerplate in C, just creating a socket, bind, listen. We accept the input data TCP part, and then we connect to both of our subscribers. And this is like the naive example, so just using read-write. So we read some bytes from the source, then we write those to the first subscriber, and we write those to the second subscriber. And at the end, I just print the usage that it took from the CPU. Like so, except I should run the bench, this version, so that it's a bit faster. And yeah, so that doesn't show you much, but now I'm gonna rewrite the exact same thing, but with splice and tee instead. So we're gonna go to this proxy.c file, which is same exact content, so I still have a source and two subscribers, which are just, yeah, TCP endpoints. And in the for loop, instead of using read and write, we're going to use splice and tee. So I realized that I haven't explained it, the difference between the two. So what splice does is that it transfers data between an arbitrary file descriptor and a pipe, or from a pipe to a file descriptor. And yeah, all this data stays within the kernel. There is no, you don't need to allocate a buffer or anything. It's all done inside of the kernel. What tee does is that it duplicates data from or to a pipe. I think, yeah, from a pipe. So and of course, duplicate should ring alarm bells in your head that it's gonna copy the data, but it only copies it if it needs to. So what tee is gonna do is that it's gonna make a copy, but by incrementing a reference counter. So in reality, the copy is very cheap. So anyway, let's rewrite this. So first of all, we need two pipes. So we're gonna have the main pipe and another pipe like so. Then we create two pipe like so. This. Yeah, because splice and tee only work with pipe. Actually, there is a really interesting discussion on the kernel mailing list where apparently like pipe is just, I mean, it's a bit of a weird name for like a kernel buffer. So like, yeah, a pipe in Unix or Linux is just, yeah, some kind of arbitrary buffer in the kernel. And so yeah, this is why on splice and tee use it, because it needs to be like the data needs to be buffered in some way. So let's first do splice, and we're gonna splice from the source, which is yeah, our input data. So this is like the source file descriptor. This can be the second argument can be an offset, but we don't work with files, so it should be null. Then we're gonna put the data from the source to the first pipe, like so, and it's gonna be the right end of the pipe, so the index 1. Again, it can be this one can be a file and it can have an offset, but in our case, it doesn't matter. Then we're gonna specify how many bytes we want to copy. This will be chunk, same thing as the naive proxy, and then there is a bunch of flags, but let's ignore them for for this example. And we're just gonna make sure that if there is nothing to copy anymore, we're just gonna stop the loop. Next, we need to duplicate. So for now, right now, we've moved the data from the source into a pipe or a kernel buffer. Next, what we need to do is duplicate this data from the main pipe to the sub pipe. So let's do this. So it will be main from the read end into the right end of the second pipe, like so. It will be for the same size that we spliced. And again, I think T has some flags which we can ignore in this example. After that, we can. I guess we could reuse. Oh no, we cannot. Yeah, it doesn't matter. Next, we need to. So now we have two pipes or kernel buffers which have the data because we just teed them. And next, we need to just put the data from these two pipes into the two network sockets that we have as subscribers. So let's put main 0, which is the read end, into, again, we need an offset, and then it will be sub-0. The offset is again null. The length can be just n, and the flags can be 0, and we can do exactly the same for the sub pipe into the other interface, like so. And that's it. That's our example. And you see that at no point I had to use like a buffer of my own. I'm just manipulating pipes and file descriptors, and it worked out this way. So now let's go for the actual interesting part where we compare the performance of the two. I mean, of course, I wouldn't be making this video if the splice and T version wasn't faster, but let's do it anyway. So this was the naive option, which takes I don't know about how should I read this? I forgot. Yeah, total. So the total took like 0.03 second to execute, and the second one was about 3 times faster. So you can see that there is a significant difference. Maybe if I increase the size of the data even more, the difference will be even greater. Oh, I realize that you can't see this with my camera. Can I scroll? No, I cannot. Let's just do this one more time. But yeah, my point is that it's just much faster, and of course, well, okay, it's not faster because you're limited by networking, but the CPU consumption is much lower here. For example, we instead of spending all this time in the system, we spend a bit less than half of the time. So it's a very efficient way of transferring data around inside of the kernel. So yeah, and of course, if let's say you have a server which is, for example, an HTTP proxy or whatever, where it only needs to read the HTTP header, but it can splice the body. You can see how that would save a lot of copying around of large bodies. And if you have just a huge amount of clients and a huge amount of servers behind the proxy, you start getting limited by CPU, and then this kind of tricks can help you a lot. So anyway, I hope you learned something about T and splice and more zero copying, well, quote-unquote zero copying inside with the Linux kernel, and I'll see you in the next one.